Hello, we are going to talk about significant figures. Significant figures is a tool we use to know how accurate a number we really have. And I'll talk about that a little bit more. We can have two types of numbers. We can have, results. We can have very accurate results, or we can also have results that are being really precise, meaning if you are doing a laser beam and you kind of shining it at a place off of several mirrors, and you did all the calculations, and you know that your theoretical value is supposed to be at some coordinate, let's say 0, 1. And let me just draw this so it makes it more fun and pretty. So let's say, this is just a random example right now. Let's say we have this laser right now, right? So this laser, well, what a beautiful laser. And we're shining light. And we have a mirror right here. And then we have a mirror right here. And let's say your theoretical value is telling you that if this is like an, I don't know, three-dimensional situation where we know what coordinate this point really is, and we say this point is at 0, 1, and 2, and I'm just making up numbers, right? Then a accurate, and this is your theoretical value, meaning that if all conditions are fantastic, no damping, no nothing that really can alter your results, you should end up with that solution. And so if you end up with a solution that is very close to it, like 0.0001 comma and then 1 and comma 2, then you're pretty accurate, because you're just off by 10 thousandths, right? Because that is tenth, hundredth, thousandths, 10 thousandths, and that's where the error occurs. But if you are precise, meaning this is your theoretical value, and let's say you do a trial and you end up with, let's say, -1, 2, and 2, right? And then you do the trial again, like trial number 2, and you get -1, 2, and 2, and then -1, 2, and 2. Then you have precise solutions. You have your data is pretty precise. You end up with the same error every single time when you know that your theoretical value is supposed to be this. Anyway, so that's accurate, which is this guy, or we can have precise, which could be something like this. Anyways, let's move on. So what is significant figure? I guess I already answered that. It's a way for us to figure out how accurate our answer really is. When to use significant figures? I know that this is going to be hard for me to keep saying significant figures. We use them in situations where accuracy really matters. For instance, in a laboratory, you may want to care about significant figures if you are an alien ship that wants to take over Earth. Let's just new. Bam. Let's say you like this alien ship right here, and you know this is Earth, and an alien ship typically has something like this going on. Anyways, and then let's say this is, I don't know, 3 light years away, which 1 light year is huge. It's a big distance. So let's say we're 3 light years away, and then this captain is saying to whoever is navigating the gun, all right, let's shoot. Let's shoot the laser beam. And then the captain says, at what angle do we need to shoot in order to hit them? And this guy says approximately 45 degrees. Yeah, you're not gonna hit this planet at all, because your answer needs to be very accurate. This guy should have come out with like 44.8719200045 ... He should have gotten you a really accurate answer in order for you to successfully hit the Earth, and that means that you need lots of sig figs. Don't you like how I come up with a example that explains the importance of sig figs using the example of an alien invasion? Alrighty, let's move on. So when do we use significant figures? In laboratories. Now if you're one of my students, you don't really have to draw the planet and the ship that attacks the planet, and you just have to pretty much write down when do you use significant figures. Laboratories, and if you want to go above and beyond, you write down in places where accuracy really matters. Alrighty. Yeah, that's pretty much the same thing. When to use significant figures. Wow, I had an animation to this. That's awesome. And I did not follow through. Let's say, oh, I was supposed to come here and come up with an example. Alrighty. So this is, alright, let's come up with another one since I already did that. So let's say we have a pirate ship and he has an island. And this pirate ship is called the Black Caribbean. And then over here we have Captain Hook, who is actually from Peter Pan. I don't know why I'm coming up with Captain Hook. So they want to shoot Captain Hook, and they know Newton's laws and everything, and the equation for the 3 equations that we're going to go over in later lectures on predicting with what velocity we need to shoot in order to hit our target a certain distance away. Turns out that if you say that instead of using gravity equaling 9.8, which is the average amount of the average value of gravity on Earth, we actually have different gravity values on different parts of the Earth. If you just say, let's just go ahead and use gravity equaling 10, right, which is just one significant figure versus having 2, then you will probably miss Hook. You're probably going to hit him right here, or you're going to hit him right there. So significant figures are pretty important. And the reason why I remember this is because one time I was careless and I used 10 for G, and I wasn't able to get the correct answer. Alright, anyways. To be a scientist, you need to know significant figures. Let's skip that slide. Okay, so how do you know how many significant figures you have? Well, there are probably many examples. I probably should talk about that first. Significant figures is a very important topic because some people really get it wrong, and I want to make sure that we're good. Let's talk about the case when we don't have a decimal. And maybe the way I'm explaining it is not the way that any teacher wants to explain it, but let's talk about the example when we don't have a decimal. So no decimal. So when we have no decimal, and let's say we have 10 to 4, let's put a 3 right there, 0, 0, right? Then the only significant figures that we have in this case is this guy, this guy, this guy, this guy, and this guy. We have 5 significant figures. And that is because one might think that the zeros back there were estimated, meaning maybe the true value wasn't, what is this, 1,023,400. It might be 1,023,407. But someone said, okay, let's just drop the 7, make them zeros. So as a rule, zeros, and I want to write 0 but I put an S there for some reason, zeros at the end don't count. So notice how this 0 did count, but these 2 did not. That's because this 0 is not at the end. It's between actual numbers. It's that these 2 zeros are actually at the end, so they don't matter. So that's when you have no decimal. When you have no decimal, significant figures is very straightforward. When you have something like this, you only have 5 significant figures. And then also, if someone was to give you this number, which is identical to the number we just saw right now, then it would be crazy to use this because this doesn't make any sense. So zeros at the end don't count, but also let me just go ahead and do this. And front don't count either. So these zeros don't matter, these two zeros don't matter. It's just the numbers in between. So zeros on the outsides don't count. Zeros in between are fine. They are completely fine. Now this is pretty straightforward, and I'm pretty sure no one has a problem as long as there's no decimal. But when there is a decimal, then things are starting to get real. So here's an example. So the Facebook guy, I don't know how much he's worth. He's probably worth 16 billion. Let's say 980 million, and then 478,281, right? Now if I'm the guy from Wikipedia and I want to put down how much he's worth, I'm gonna say 1.16.98 billion dollars. Let's say I say this. Let me put the dollar sign. Right? $16.98 billion. Or maybe they say $17 billion. 17 billion. Well, the significant figures in this case is only 2. Only have 2. Because that's equivalent to saying 17 and then 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? So this is not really, these zeros don't count because they might have been estimated. But let's say I do put a decimal. So right now we're talking about with decimal. So when you have a decimal happening, like let's say we put a decimal right here, then all of a sudden we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 significant figures. Did I count this correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because we are saying he has exactly $17 billion, right? He doesn't have, if this is not there, so let's say that's not there. If this is not there, he has roughly 17 billion, right? But if this guy is there, if you have a decimal, he has exactly 17 billion. So that's the difference. When we know exactly that it's 17 billion, these zeros that first didn't matter do matter now because they're right there behind the decimal. Alrighty. Now the question becomes, what happens if I attach another 0 right here? So that's this right here is 11 sig figs, right? Let's say we have the exact same number, exact same one, and I put another 0 right there, right? Well, that would be 12 significant figures. Because I'm not just saying that this guy has $17 billion, but I'm also saying he has exactly, he doesn't have any, let me put another 0. So let's make that 13. Not only does he have $17 billion, but he also doesn't have any cents happening right there. He doesn't have a cent over or under 17 billion. Like in the example above, maybe there was 1, so he had 11 cents, but we kind of rounded it off. Over here we're saying he has exactly 17 billion to the cent. And if you're not talking about money, so let's go new. Nope. When we if you're talking about something that's not money, then we can go as far as we want. 1, 2, 3, 4, 5. And because there's a decimal, we have 1, 2, 3, 4, 5, 6. 6 sig figs. That's why these scales can be really expensive. There are these scales out there that that look like this: empty box, decimal, and then empty, 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 empty. And then these can be really quite expensive because this scale is claiming that it can estimate to the nearest 10, hundreds, thousands, 10,000s, 100,000s. That's a really accurate scale. So that's why this scale, every time it gives you an answer, will have, if these are numbers and not zeros, like let's say this is 11, right? Then this scale will always have 1, 2, 3, 4, 5, 6, 7 sig figs. 7. Anyways, so when it comes to a decimal, it really changes things up because it can add a lot of sig figs, right? As long as you have numbers in the front. And here's what I mean: 1.00012 has 1, 2, 3, 4, 5, 6 sig figs. You know what? Just for fun, let's put a 0 there, just to make a point. 7 sig figs. But if this was a 0 here, 0.000120, then we only have 3 sig figs. Oh, that's confusing, because now all of a sudden these zeros do not matter. Well, remember when we did stuff without the sig figs, we said zeros on the outsides don't matter, like zeros in the front don't matter, and zeros at the end don't matter. Well, adding that decimal point only makes the zeros at the end matter. The zeros at the front will never matter. These zeros that we have up here really don't matter. And that's because I can easily say, instead of, let's see, 1, 2, 3, 4, 5, 6, I can easily say 12 micro on whatever I'm talking about here. Oh wait, no, sorry, 120 micro. And let's say this is meters, micrometers, right? Where we put a decimal right there. Since we have a 0 here, we are saying that this is definitely 0, so we have to put a decimal. Otherwise, we're breaking some kind of law, I think. Anyways, this is gonna have only 3 sig figs. You see how using a prefix can kind of get rid of this. Anyways, so just pretty much going over, when there's no decimal, front, back zeros don't matter. When there's a decimal, front zeros don't matter. Anyways, so I just want to kind of cover that, and everything else we can do quite quickly because I think I wasted, not that I wasted, I would love to be here forever and talk about this with you guys, but I don't want to waste your time. Anyways, so how many sig figs do we have here? And my students are gonna write down these numbers, and next to them they're gonna write down the solution. Now if you want to pause the video and kind of do it yourself, that's great, but I'm about to read off the answers. The first one has 2 sig figs. The second one, when I talk about the second one, I'm going downwards, so whoa, no, okay, I'm going downwards, so the second one to me is 2100. So the second one has 2 sig figs because the 2 zeros don't matter. The third one has 4 sig figs, 56.76. That's 4 sig figs. The fourth one has 3 sig figs because I'm not just saying this is 4. I am saying this is exactly 4, and I'm confident to the 100th. The fifth one is 3 sig figs. The sixth one is, let's see, that's 4 sig figs because the zeros towards the right don't matter. And then the 3401, that is 4 sig figs. The 2100 is 2 sig figs. The 2 zeros at the end don't matter. Now the bottom one has 5 sig figs. That decimal made a difference. Now the zeros at the right do matter. The 5.00 has 3 sig figs. Then the 0.00412 has 3 sig figs, because no matter what, the zeros at the front, to your left, do not matter. And the very last one, 1, 2, 3, 4, 5, 6 sig figs. 6 sig figs. If you got all these answers correctly, give yourself a high five. You try, and by that I mean do it mentally. You don't have to write this in your notes. And I'm about to start reading these out loud again. So this is 4 sig figs, the very top. Then we got 2 sig figs. Then we have 5 sig figs. Then we got 3 sig figs, that's the 5.00. Then we have 3 sig figs again, that's the 0.00412. And then the very last one, that huge number, which is really similar to the one I have in my bank account. That is 1, 2, 3, 4, 5, 6. No, that's 6, right? Let's see. 1, 2, 3, 4, 5, 6. 6 sig figs. And if I was to put like a decimal right here, it would have automatically added these 4, making it 10 sig figs. Unfortunately, we are not done yet. You know why? Because this is a fortunate situation. I know you want to learn more. What about calculations with sig figs? When we add and subtract, and when we do adding and subtracting, apparently I didn't do any more PowerPoints slides. I'm just gonna go ahead and do a few really quickly, so just bear with me. And the funny thing is, you guys are watching a video on YouTube. Imagine this would still take me another 10 minutes, and then you're sitting there and the guy just said just really quickly, and then you look at the bottom and you see another 10 minutes are left. It's like, yeah, right. Anyways, I'm going to be doing this really quickly. So let's say we have 2.00 and we're subtracting 2 from it, right? When this is happening, you would end up getting a solution of 0. You would only have one significant figure, according to this guy right there. Now, obviously, this has, I guess, this has no significant figure. I wonder what happens when you only have a 0. How many significant figures does a 0 have? You know what? You guys kind of look it up on Google, okay? But let's say I can't let that happen. Let's say we had 2.001 minus 2.1. That would give you negative, let's fix that, negative 0.1, right? We would only have one. Actually, I take that back. This has 2 significant figures. This has 3 significant figures, which means that I am supposed to write 0.10, because when I subtract these 2 numbers, I subtracted a number that had 3 significant figures from a number. I subtracted a number that has 2 significant figures from a number that has 3 significant figures. And when I do that, my answer can only be as accurate as the least accurate number. Because the thing is, if I'm subtracting a number from, this can be as accurate as you want, like 2.000000005, right? If I'm subtracting like 1 from that, right? You can't say this is going to be 1.00000, because you just jeopardized your answer because you're subtracting an answer that's not accurate at all. So therefore, this is just 1. Your solution is just 1. That would make me pretty mad. If I came up with this number and then the other guy was supposed to come up with this number, and I did all this work, and the guy goes like, yeah, I just subtract 1 from it. Like, what are you talking about? Do you know how many people? Anyways. Yeah, I ended with slides. Multiplication, I mean, if you did addition, it would be the same thing. So, by the way, if you did this in your notebooks, write it nicely and properly. That equals 1. You have, you can write down how many significant figures this has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 10 sig fig subtracting a 1 sig fig will give you a solution of 1 sig fig. The same thing would have happened with addition. If we do the same thing but with addition, like 3.001 plus 3.0, then our solution is going to have to be 6.0, because our calculator would have probably given us 6.0001, but we have to round to two significant digits, because the lower number, the less accurate one, was only 2 sig figs. Alrighty, that's with addition and subtraction. Multiplication and division is virtually the same thing, except you're multiplying and dividing. So what would have happened here is, well, I do not want to save it, I just want an empty blank. What would have happened here is, if you do like 5 minus 2.0, divided by 2.0, then your answer will be 2.5, right? But imagine you did 5 divided by 2 scientifically, then your answer needs to be 3, because this only has one significant, oh wait a second, this only has one significant figure. This needs to be 3 too. This has to be 3, because this number is not accurate. Now, had this been, let me cross this out, you don't need to write this one down. Had this been 5.0 divided by 2.0, you would have gotten 2.5. Accurate to 2 significant figures divided by something that's accurate to 2 significant figures will give you something that's accurate to 2 significant figures. 5.001 multiplied by 0.0012, our answer should have how many significant figures? You guessed it, 2. However, I do not know what that is when you multiply them. Let's go to program. Oh, I just had it right there. 5.001 times 0.0012. Bam. Okay. What was that again? Totally forgot. 0.0600112. I think that's another 0 here. Yeah. Anyways, our solution needs to be 0.0060, because this has 2 significant figures, and so does this guy. That's supposed to be decimal, right? I think that was a decimal. Yeah, I kind of forgot whether that was a decimal. Well, let's see. We multiply by. Yeah, that looks like the right thing. Yeah. Anyways, so that's how you kind of deal with it. And that's all for today's lecture. I wish you guys the best, and I really apologize for my videos to be this long. I'm still getting the hang of it. Hopefully my next video should be way less than this. Have a fantastic day.